All right, folks, section 4.1, identifying and graphing sequences. Now, in this section, we're going to talk about two major sequences, the explicit sequence and recursive sequence. Now, they're two very different sequences. Explicit's very straightforward and rather simple, something I think you guys will easily understand, but recursive is sort of a new spin on it. So it's going to take just a second to really understand how recursive works. Now, to explain what a sequence is a sequence is simply just a list of numbers in a specific order. And each number is considered a term. So if you look at the sequence here, 7, 9, 11, 13, and then it repeating means, or not repeating, but the dot, dot, dot means that it would continue, right, to 15, 17, etc. This is a sequence because it's just a list of numbers. And 7, 9, 11, 13 are all terms in that sequence. 7 is the first term, 9 is the second term, 11 is the third term, right? So on. So pretty simple, right? Just a list of numbers. Now, in this particular problem, we're going to look at just kind of the introduction of a sequence regarding this go-kart, the number of laps it completes. So it says that the go-kart racing track charges $5 for a go-kart license and then $2 for each lap. So if you list for charges for 1 lap, 2 laps, 3 laps, so on, the list was 7, 9, 11, 13. So if you go to the go-kart track and you race 1 lap, then in total, you're going to be paying $7. It's $7 because you're paying $5 for the go-kart license and then additional $2 for that lap. And then if you want to do 2 laps, you're paying $9 because you're paying $5 for the license, $2 for the first lap, and $2 for the second lap. If you go for 3 laps, you're going to pay $11 because you're paying $5 for the license and then $2, $2, and $2 for each lap, making your total 11. So as you increase, you're adding essentially $2 every time because every additional lap you go, you pay another $2 for that lap, right? So the 4th lap or 4th term will be 13. The 5th lap or 5th term will be 15. And then our 6th lap would be 17. So 1, 2, 3, 4, 5, and 6 indicate the lap number, but they also indicate the term of the sequence or the position of each term in the sequence. 7 being the first term, 9 being the second, 11 being the third, and so on. And these values represent the price of going to go-kart. Now, to make sure we're clear on our notation, f of 1, the way that's written and the way that's pronounced, f of 1, means the cost of 1 lap. And the cost of 1 lap, as we mentioned, f of 1 is 7. Or it also means first position, not in the go-kart track. I'm talking about in the sequence, the first number in the sequence, first term in the sequence. I should really say term. First term in the sequence, 7. F of 3 means the third term in the sequence, which was 11. F of 6 means the 6th term, which is 17. 13 was the 4th term, so it's f of 4 because it's indicating the 4th term was equal to 13, so a little backwards from the first few. And then f of 5 is 15, or essentially the 5th term is equal to 15, or the 5th term is 15. So identify the domain. The domain, again, is our x values, or the position values in this case, which is just 1, 2, 3, 4, 5, 6. And then our range is the actual price for those laps. So 1 lap, remember, $7, then 9, 11, 13, 15, 17. So what does f of 4 equals 13 mean in the context of the go-kart problem? F of 4 equals 13 means the 4th, well, I guess, okay, so 4 laps costs $13, right? The 4th position, or the 4th term in the sequence is 13, but in terms of the go-kart problem, it means that 4 laps was $13. All right, explain how to find the missing values in the table. Well, we noticed that the term, what did they call it up here? The position number, okay, so position number was increasing by 1. And then, so that was the position number. You'll notice all those are increasing by 1. And then the term of the sequence, these are all increasing by 2. So terms increased by 2. Terms increased. I don't know why I spelled it out this time, but not the first time, increased by 2. Okay. So now let's talk about these sequences. Okay, so that just gives you an idea of a sequence. It's just a list of numbers in a specific order. So what we're going to talk about now is the explicit rule, explicit sequences. Now, an explicit sequence is a sequence that defines the nth term as a function of n. So basically, if you want to find the, let's say, 12th term in a sequence, you would just plug 12 in as n. N represents the position in the sequence. So if you want to find the 12th term, that's the 12th position in the sequence, you would just plug 12 in for n, and the outcome result is the 12th term. So if we want to find, for example, the first 4 terms, then what we're going to do is we're going to plug in the numbers 1 for the first term. We're going to plug 2 in to get the second, plug 3 in to get the third, plug 4 in to get the fourth. So the explicit one is very straightforward, because whatever term you want to find, whatever position term you want to find, you just plug that position in, and the outcome is that term. So for example, right, you want to find the third term, you plug 3 into that function. The third term is 11. So the first problem is already done for us. The first 4 terms, when we plug in 1, when you plug in 2, when you plug in 3, when you plug in 4, the outcomes were 3, 6, 11, and 18. So the first 4 terms of that sequence are 3, 6, 11, and 18. Just a list of numbers again, right? But this list of numbers goes based off of that function. So let's try one out for ourselves, right? F of n equals 3n squared plus 1. So we want to find the first 4 terms. So that what we want to do is we want to plug in 1 to get the first term, plug 2 in to get the second term, plug 3 in to get the third, plug 4 in to get the fourth. So that's exactly what we'll do. So you see this table's over here to kind of help us get organized. So f of 1 means that we're plugging in 1. Remember here our function is 3n squared plus 1. So that means we're going to have 3 times 1 squared plus 1. Now when you do this math, 1 squared is 1, and then multiplied by 3 makes it 3, because 1 times 3 is 3. And 3 plus 1 ultimately becomes 4. So our first term in the sequence is 4. If we want to find the second term, f of 2, meaning the second term, we plug 2 into our function. So we'll do 2 squared. 2 squared is 4. When we multiply it by 3, 4 times 3 makes 12, and then plus 1 is 13. So our second term is 13. So all I'm doing here is just plugging it in the function. Okay, the third term, plug in 3. 3 to the second power is 9, and then that times 3 makes 27, and then add 1 is 28 as a result. So our third term is 28. And then lastly, if we want to find the fourth term, we plug in 4. So 4 to the second power is 16. Multiply it by 3, that's 64. No, I'm sorry, not 64. That's 48. And then 48 plus 1 is 49. So our fourth term is 49. So remember, we plugged in 1, 2, 3, and 4 because we were asked to find the first 4 terms, right? And our first 4 terms are 4, 13, 28, and 49. So you definitely use a calculator. I know I was doing that kind of without a calculator. Some of us might kind of rely on the calculator, and that's okay. There's nothing wrong with that, but just know what you're supposed to do, right? Know you need to plug in the number, let the calculator do the math for you if you have to, okay? So explain how to find the 20th term in the sequence defined by this explicit rule. So just explain how to. No, don't actually find it, just explain how to. All right, so to find the 20th term, to find 20th term, just plug in 20 for n. So you would just basically, you would have the 20th term, f of 20, remember that just means the 20th term, is equal to 20 squared plus 2, because it was n squared plus 2, and you're just putting 20 in for n, So you're making 20 squared plus 2. We're not going to solve it. It didn't ask us to solve it, but that's how you would do it, right? You want to find the 20th term. You don't have to find the first 19 terms in order to find the 20th. You could just plug the 20 in, and it'll tell you what the 20th term is. That's the beautiful part about explicit sequences, is you don't have to find all the previous numbers before it. You can just plug in 20 and get the 20th term without having to do anything else, without having to find any other term, which is nice. Now, the number 125 is a term in the sequence defined by the explicit rule f of n equals 3n plus 2. Which term in the sequence is 125? Now, number 5 is a little different because it's not asking for the 125th term. It's saying that somewhere in the sequence, right, is 125. And it's asking, well, which position is it? Is it the third term, the fourth term, the fifth term? What is it? Right? That's the question. It's really asking for n. What's the value of n? N equals question mark. That's our goal. We don't know which position that term is. But here's how you can find out, right? 125 is your f of n value, not the n value. You're not plugging 125 in for n, but you're plugging in 125 for f of n. So you're making this equation, 125 equals 3n plus 2, right? We're using this function, but we're plugging 125 in for the term spot, right? Not n. We're trying to figure out what n is. We want to know which position, comes out to equal 125. So it's just a little bit of algebra. We subtract 2, cancel that out. That's going to be 123 equal to 3n. And then when you divide by 3, I believe this comes out to be 41, I think. Okay, and it's 41. So what that means is that 125 is the 41st term. Okay, so you might need to rewatch that, what I just did there, to sort of really let it sink in a little bit. I would say it's definitely worth rewatching because it can be a little bit confusing, the fact that we're kind of doing the problem a little differently than we did like number 4, for example. So number 6 and 7, let's practice this. Okay, so number 6, write the first 4 terms of the sequence defined by the explicit rule, f of n equals n squared minus 5. So we're looking for the first 4 terms. I like to draw my list out and then fill in the spots. So in order to find the first term, that means I just got to plug in 1, right? Our first term is 1 squared minus 5. Now 1 squared minus 5, so 1 squared is just 1, and 1 minus 5 makes negative 4. So my first term is negative 4. If I want to find the second term, then I will plug in 2. So we'll do 2 squared, right? Because we're following our function up here. N squared minus 5, so we're doing 2 squared minus 5. 2 squared is 4, and then 4 minus 5 is a negative 1. So second term is negative 1. If I want to find the third term, I'll do 3 squared, right? Plug in 3. 3 squared minus 5. That's 9 minus 5, which is equal to 4. So my third term is 4. And then lastly, if I want to find the fourth term, I'll plug 4 in. So 4 to the second power minus 5. That's 16 minus 5, which is 11. So our fourth term is 11. So there's our answer. Negative 4 is our first term. Negative 1 is the second. 4 is the third. And 11 is the fourth. All right, now number 7, find the 15th term of the sequence defined by the explicit rule. So remember, we don't have to find the first 14 terms in order to do this. If we want the 15th term, we can just plug 15 in for n. That's the nice thing about the explicit rule. So that means that the 15th term, f of 15, just indicating, remember, that just says the 15th term, is equal to 4 times 15 minus 3. So our 15th term this is going to be 60 minus 3, which is equal to 57. So our 7th term, or our 15th term, is 57. All right, so now let's move on to part 2 of this, the recursive rule. So a recursive rule for a sequence defines the nth term by relating it to one or more of the previous terms. Now, here's the difference between this and the explicit rule. With the explicit rule that we just covered, we did not have to find all the previous terms in order to find a specific one in the sequence. So for example, if I want to find the 15th term, I did not need to find the first 14 in order to get the 15th, because I could just plug 15 in. But with the recursive rule, that's not the case. With the recursive rule, you have to find all the previous 14 terms in order to get the 15th term. And the reason why that is because each term depends upon a previous value. So you're not plugging in 1 to find the first term here. You're not going to plug 2 in to find the second. It doesn't work that way. You're going to be plugging in the results of the first and second or third term. You're actually going to plug the terms before themselves in. Let me show you what I mean. So in this example, we have it's saying that the first term is 4, right? So in this sequence, the first term is 4. That's what f of 1 equals 4 means. The first term is 4. Now our function f of n equals f of n minus 1 plus 10 is our rule. Now this looks fancy, right? But all the f of n minus 1 means, every time you see this, I really need you to make sure you understand that. F of n minus 1 just means previous term, okay? So I always cover it up with a PT. PT, okay? Previous term. You are not plugging anything in for n. You're not plugging in anything for f. You're actually just taking this whole thing and putting the previous term in that spot. And you'll see how I do that later on. But I'm going to write it down, something you can make a note of somewhere. F of n minus 1 equals previous term. Okay, previous term, very important. So, if I were to find, we're going to use, if I were to find the second term of this sequence, right? If I want to find the second term, then I'm going to be using the previous term to find it. So to find the second term, I would plug in the previous term. The previous term was 4, right? So we'd plug in, this whole thing would be 4, and then you'd add 10. 4 plus 10 to make 14. So the second term is 14. Now, just to keep it going, if you want to find the third term, you would plug 3, or not you wouldn't plug 3 in, I'm sorry. If you want to find the third term, you plug in the previous term, which is 14, right? Because 14's the second, and it's the one right before the third term. You plug 14 in where that is, and then you add 10. 14 plus 10 is 24. So it looks like a lot of fancy math stuff, but really, if you want to, you could just cover it up that entire time and just say, previous term. So that's what the formula means, the previous term plus 10. So if you want to find the fourth term, then you plug the previous term in, which is 24, and then you add 10, which makes 34. And that's how it essentially works. That's why you can't you're not plugging in 4 to find the fourth term, right? So if you want to find the 8th term, you can't just plug 8 in. What you would have to do to find the 8th term is you would have to find the 5th, the 6th, and the 7th term, because you're going to need to plug the 7th term in order to find the 8th term. So you actually have to find all these other terms in order to find the next term in the sequence. Okay, so if you look at the example that's already worked out for you, f of 1 equals 2. This is saying the first term is 2. So, of course, you can see that the first term that's written is already 2. But the rule states that the current term is the previous term. Remember right here, that f of n minus 1. Okay, that just ignore it, right? Just cover it up with a PT for previous term. It means previous term plus 3. So our first term is 2. But if we want to find the second term, we plug the previous term in, which is 2, right? And then we add 3. 2 plus 3 makes 5. So our second term is 5. If I want to find the third term, I plug the previous term in, which is 5. Then, of course, remember the formula is that plus 3. So 5 plus 3, which makes 8. So my third term is 8. If I want to find the fourth term, I plug in the previous term, which was 8. And I get 8 plus 3, which is 11. So our fourth term is 11. So that's how they're getting all these values right here. So every term relies on the previous term. You can't. Keep in mind, you're not plugging in 2 to find the the second term, or you're not plugging in 5 to find the fifth term. You're not going to plug in 9 to find the ninth term. That's the explicit rule. That's how the explicit rule works. But when it comes to recursive rule, you have to find that term and plug that term in order to get the next one. So let's try it with this example. So this example says that the first term is 4. And by the way, just a side note, recursive sequences will always give you the first term because they have to give you the first term. The only way you can find the second term of the sequence is by plugging the first term in. So they have to tell you what the first term is in order for you to use it and find the second term. And then you can use the second term to find the third. You can use the third term to find the fourth, and so on, right? It continues on that pattern. So our first term is 4. We already know that. That was given to us. Now, remember, this right here, f of n minus 1, get used to seeing that because what that means is previous term. So just think previous term and then plus 5. That's what this sequence means. Sequence is previous term plus 5. So if I want to find the second term, oops, gotta add 5. I want to find the second term, I plug the previous term in, right? My first term was 4. If I want to find the second term, I plug the previous term in, which is 4, and then plus 5. 4 plus 5 is 9. So 9 is the second term. If I want to find the third term, right? Oops. Then I'll plug in the previous term now being 9. So 9 plus 5, which is 14. So my third term is 14. If I want to find the fourth term, I plug in the previous term, which was 14. So 14 plus 5, which makes 19. Right? And that fills up those first 4 terms. Now, just to fill in this notation to kind of briefly explain what it means. If this confuses you, then you could just bypass it. But I'm going to explain kind of the math reasoning behind this real quick. So what this means is that the second term equals f of 1 plus 5. F of 1 means the first term. F of 1 was 4, which is why you plug in 4 plus 5 in order to get 9. F of 3 means the third term, and that's going to be plugging in f of 2, which is the previous term, because f of 2 meant the second term, right? Which f of 2 was 9. So you're plugging 9 plus 5, which gets 14. And f of 4 equals f of 3, this meaning, again, the third term. The third term was 14, so you're plugging in 14 plus 5 to get 19. Okay, so that's what that all means. And just to fill this in, the domain of the function is 1, 2, 3, 4, again, because you're finding the first, second, third, and fourth term, but you're not actually plugging those numbers in, keep in mind. What you're really doing is plugging in the outcomes in order to get the next outcome, plugging in 9 to get the 14, plugging in 14 to get the next term of 19, and so on. All right, so the first 4 terms are, let me put these back in here, 4, 9, 14, and 19. All right, so number 8, describe how to find the 12th term of the sequence in 2a. Well, you have to find the first 11 terms first. Okay, then plug in the 11th term to find the 12th term. Okay, sorry for the sloppy handwriting. Again, I'm doing this with the screen kind of vertically, so it makes it a little harder on my wrist, but it's fine. I read it to you, it's all good. So just to say number 9 without writing it. So suppose you want to find the 40th term in the sequence. Would you rather use recursive or explicit rule? Well, to answer number 9, I would rather use the explicit rule. The explicit rule means that I could just plug in the 40 into the function and I'd have my answer right away. The recursive rule would require me to find the first 39 terms and then find the 40th. So I'd have to do it 40 times in order to find the 40th term. Whereas with the explicit rule, I could just plug in 40. I don't have to find the first 39 terms. Just plug in 40 and I would get the 40th term, which is really helpful. But you can't you can't have it both ways. So recursive is recursive, explicit is explicit, and they don't really alternate. So number 10. F of 1 equals 35. F of n equals f of n minus 1 minus 2. So what this says is that our first term is 35. Wants us to find the first 5 terms. And remember, our formula is, this means, remember, get used to seeing it. Again, I'm going to repeat it over and over again. This means previous term. So we have previous term minus 2 is our formula. Previous term minus 2 is our formula. So to find the second term, I plug in 35, and I do minus 2. So 35 minus 2, which is 33. In order to find the third term, I plug in the previous term, which is 33 now. 33 minus 2 is 31. If I want to find the fourth term, I plug the previous term in, which is 31. 31 minus 2 is 29. And if I want to find the fifth term, I plug in the fourth term, right? I plug the previous term in, which is 29. And 29 minus 2 is 27. And those are the first 5 terms. Okay, so let's do it for number 11 as well. So number 11, our first term is 45. So our formula says right here, previous term minus 4. So our formula is previous term minus 4. So our previous term, if I want to find the second term, the previous one was 45. So 45 minus 4 makes 41. To find the third term, we plug 41 in. 41 minus 4 is 37. To find the fourth term, I plug the 37 in. 37 minus 4 is 33. And then plug in 33. 33 minus 4 is 29. And there's our final answer. Okay. I'll come back and do these word problems in the future. It's essentially the same thing, just plugging in numbers, but you just plot them on the graph. So it's pretty much sort of the same dealio. All right, I'll let it go for now. I'll see you guys later.